In the previous program, we have handled the problems of power supply and also the brightness, focus and intensity problems. These problems were mainly created by power supply. But there are other ways also to localize the faults, such as the symptoms available on CRT screen. And by seeing the CRT screen symptom, you can get idea where is the fault. Therefore, first try to understand the working principle, at least based on block diagram. Here in block diagram, this is horizontal stage of an CRO, in which this area is known as triggering area, and this area is known as sweep generating area, and this is horizontal output area. Since all the three stages are interconnected, therefore problem in any of these area will be cumulative on CRT screen, but one will get idea which is the stage that is creating problem. Here we have received one oscilloscope for repair purpose. Let us see what is the problem in this oscilloscope. Switch on. The pilot lamp indicates power is going inside. Beam is also on the CRT screen, but only up to halfway. No, it is coming only up the halfway, not covering the full screen. Therefore, there is some problem in horizontal stage, which may be in horizontal output stage itself. Let us see the block diagram once again. The role of sweep generator is to generate sawtooth, and these sawtooth are amplified in the horizontal output stage. Since the problem in oscilloscope, beam is going only half the way, it means sweep generator is working. That's why you are getting the beam. Problem seems somewhere in the output stage. So let us check this CRO again. What is the problem in output stage? To repair this oscilloscope, let us first consult this service manual of this oscilloscope. which is here. Horizontal stage is here. Let us find out where is this module really in oscilloscope. Let us search the horizontal PCB in this CRO. Which is here. This is the horizontal stage PCB. This is the horizontal stage, and these are horizontal output transistors. Since these are coming from this area, it means your fault lies somewhere in this region. It is the circuit diagram of the horizontal stage of defective CRO, and these points are going to CRT X1 and X2 plate and coming out from this area. This is the amplifier for one plate, and this is the amplifier for the next plate. Since your signal is amplifying only to one direction, it seems only one plate is working. Therefore, check systematically whether this plate is working or this is working. And they are bifurcated from this point, so let us start from here and see the sawtooth is coming. To repair this oscilloscope, we have to study the path for sawtooth, and sawtooth you can see only by another CRO. Therefore, take another CRO, and before using it, ensure that its probe is perfectly adjusted for frequency compensation. Otherwise, it will become difficult for you to analyze whether your wave shape is defective or the measuring CRO is defective. Let us trace the path of sawtooth in faulty CRO. We should start from the horizontal output point going to X plate. No output, no output, no output. Yes, we are getting the point sawtooth here. It means problem is in between these 2 points. In between these 2 points, one side signal is available and another side there is no signal. Let us see in the circuit diagram about this component. Here in the circuit, this X1 plate is not getting sawtooth up to this point, where sawtooth is available here. This shows this component seems to be defective. Remove it and confirm by a good multimeter. Let us take out this component from the oscilloscope and confirm it by multimeter. The diode is here. Let us check it by multimeter for its confirmation as defective. First check the multimeter, which is okay. Put one end to anode, another end to cathode. It's showing open. Reverse it. Again open. This means this diode has gone open and confirms the defective component, replaced by new one. After replacing the diode, let us check the CRO once again. Yes, we are getting the beam and movement is on both sides also. Means we have detected the fault. We have checked that diode was defective. Suppose in case any transistor would have gone out of order, then how would have checked it? Let us see the circuit once again. We have seen this diode was defective and we have replaced and the problem is solved. Now look the circuit properly and see if any of the transistor would have gone out of order. All these transistors are DC coupled. Therefore, any defective transistor will change the voltages at every point of emitter, base and collector of each transistor. In this situation, when all transistors are DC coupled, it is very difficult to find out the defective transistor because the voltage at each and every point of the transistors, emitter, base, collector, will be different compared to the prescription in manual. To find out defective transistor, note down the readings of all transistors, emitter, base, collector voltages, and seeing the table, find out what may be the region. Here in chart, we have noted the transistor number and their corresponding emitter, base and collector voltages. Seeing this figure, let us find out which transistor is misbehaving. One should know the potential difference between emitter and base in case of silicon transistor is always 0.6 to 0.7 volt and 0.2 volt to 0.3 volt in case of germanium transistor. But in case this voltage difference is not maintained, it means transistor seems to be defective. In the similar way, if a transistor is showing collector to emitter voltage is same, it means there is a possibility that collector to emitter junction has gone short circuited. And these are the problems faced by engineers during maintenance. Check your table and see which transistor has the emitter base junction open. And as per your reading, suppose this junction is open. Remove this transistor and confirm by multimeter. In this way, you can detect the faulty transistor when the transistors are in DC coupled position. Otherwise, it was difficult for an engineer to search out the defective component, means transistor. We have received another oscilloscope for maintenance. Let us see what is problem in this oscilloscope. Put its power on. Yes, beam is here, but not full length. means length is not enough to cover the full CRT screen. And let us see what may be the fault. As we know, higher the amplitude of the sawtooth, more is the deflection. Since deflection is less, it seems the amplitude of the sawtooth is less. Let us adjust this sawtooth, seeing the position in circuit diagram. And this circuit diagram, this is the horizontal output stage, and sawtooth wave is available here and here. It means this is the width adjustment potentiometer. It is sawtooth and its amplitude is to be increased at this point, and it is possible to increase the amplitude by adjusting this preset. Here in this oscilloscope, let us find out that preset. And here in this CRO, the preset is at this point. The width control potentiometer is here. Let us switch on the CRO. This preset to cover the complete width. Let us adjust the preset. Yes, it is increasing the width. And now width is full. And this was our problem. To solve such problem, engineer have to understand the working principle of horizontal stage so that he can find out such similar problems if arising in other oscilloscope also. Here only spot is coming. It means this CRO has the problem in horizontal stage. It looks the height of sawtooth has reduced to 0, or sawtooth are not reaching to horizontal output stage. Let us see in the circuit diagram. It seems sawtooth pulse is not reaching here, either missing in the way or some problem in sweep generator stage itself. Circuit, this is sweep generator stage, and this is time division band switch to change the frequency of sawtooth. As sawtooth is not going this side, means check one by one transistor and see the sawtooth wave using good oscilloscope, and you will able to detect defective component. And in this way, let us check the path of sawtooth, and I am sure by seeing the wave shape in oscilloscope, you will able to detect the defective component where the sawtooth pulses are discontinued. We have checked the oscillator stage of this oscilloscope, and oscillator was defective because of a faulty transistor in which collector to emitter was short, and by replacing by good one, this problem has been solved. That if any of the junction or contact either in time division switch or in Y amplifier stage, it means the problem is either of the contact or some broken wire from the back side. And one should understand to analyze these faults. In the similar way, one can detect the problem in triggering stage. In the external trigger mode, external signal is fed to trigger the trigger stage. But in case of line mode, the 50 Hz mains frequency is used for triggering of the oscilloscope. Let us understand in the block diagram. Here in the block diagram, this is the trigger stage. This is the external trigger input and this is the line frequency in. You can select either internal or external or line mode for triggering this trigger stage. And seeing the wave shape starting from here to here, you can find out where the pulse is missing. In this area, problem may be less in circuit section but may be more in band switch edge.